Now we move over to look at another story which had to deal with the space shuttle, particularly the first mission of Columbia, and one of the missions that carried the radar. This is a map of Egypt. This is the Mediterranean and the Red Sea and the Nile River right here. And that strip, the red strip, is the strip of radar images that was taken by the shuttle imaging radar instrument designed by a colleague of mine by the name of Charles Alachi at JPL. And we've been working on this particular desert right here. And I wanted to ask him to get us some imagery of this area. And he said, what is it like? I said, it's absolutely flat and sand. And he said, well, that will be a waste of film. We ain't going to see a thing. So I said, but if there are little features that will show up in the radar, it will help us a great deal because we really see very little in the Landsat image. He said, no, I don't think you'll see anything at all. So I said, how about just a few seconds? He said, all right, we'll look into it. And he gave us 20 seconds of film. And indeed, it was the most interesting 20 seconds of film he has used. What turned out to be is that we have here as an image of from Landsat of the border between Egypt and Sudan. And here we see one little hill on the right and another little hill on the left. And everything else here is covered by sand, and all of these colors are different sand fields. So just flat terrain, very little to interpret. The two red lines are the 50-kilometer width of the shuttle imaging radar view that was brought to us in November 1981. So here now we see the reason behind one little hill here and one little hill here, the same ones, and that is because there is actually a river that moved out this way, and now I can see it and I can draw it right here. And there is another river that came together here. That's the confluence of the two, and then it went right here, and now I can make it up going out that way. So this here is an island between two rivers. And the third one is here, the island between that river and this very large one going out this way. So here is an area. This is 50 kilometers, this is 150 kilometers, where we have three rivers. One of them is 8 kilometers across, one is 12 kilometers across, and one is 20 kilometers across. And 20 kilometers is the total width of the Nile Valley. Not the Nile River, the Nile Valley, the whole thing. Okay, here we have three rivers, very close to each other, with that much water to form these rivers. So we thought that perhaps we should go down there and see what the story is, and we did, and went down to dig around the edge of this particular thing in here, the river right here, and we reached the ledge of that river at 16 feet deep. And down there we found all kinds of evidence of human habitation. We found all kinds of evidence of fires built by humans and ostrich eggshells and all kinds of hand axes and things of that nature, so that there is quite a bit of history all the way, dating back all the way to 200,000 years ago. At the confluence of these three rivers right here, I suggested to the Egyptian government to start a test well, just to see whether there is groundwater there, because if you have that much water, some of it would have evaporated, some of it would have gone to the mouth of these rivers, wherever they may be, and much of that water would have seeped through the rock. And indeed, they tested, and lo and behold, there's a great deal of water. Another well, and another well, and another. And they dug until 12 wells now under investigation and monitoring. And the water from these 12 wells is capable of, for supporting agriculture, in 200,000 acres for 200 years, just from one location right here, meaning that the amount of water that is beneath the surface of these deserts is enormous. So right now there is a test farm in this locality. So already all of that has grown from the local water. Here's a tanker and so on, and they have 5,000 acres of land that they're testing all kinds of crops in this particular area already, and the government is now figuring out whether to give it to little individuals or to give it to a large company for agribusiness to produce cash crops, or what to do, but nonetheless it will be utilized in agriculture. Next example will be somewhat similar, and we go back to the story of the desert. As I was saying, this is a view of the largest desert belt in the world, taken by the Apollo 11 astronauts. after the translunar injection, or meaning as soon after they finished their job around the moon and they began their journey towards the Earth. This is the view of the Earth they saw, and the Apollo astronauts usually said that the region of the Middle East and North Africa is the only part of the world they could look at from the vicinity of the moon and actually see all of the topographic features and figure out the geography. The reasons go back to what I was saying. First, the desert is clear of clouds. Every white thing that you see in this picture are clouds. The dark areas are the oceans, but also the vegetated land. Here is, you see in here all of North Africa, and there is the rest of Africa, and there is the Arabian Peninsula, and here is the Red Sea and the Mediterranean and so on. See Europe, even though it is not cloud covered right here, but you don't really see much at all because of the vegetation right here. And the colors are very much like the dark colors of the water. And here we can see the colors of the desert, and all of these colors are meaningful chemically. So one could figure out exactly the chemistry of this land if we know what the reason for that particular color is versus this and so on. Now, when we compare these deserts to each other, the best comparison we can come up with is an aridity index, which measures the amount of solar radiation that is received on any part of that desert to the amount of rain that actually comes to that same surface area. In the middle of this huge belt of the deserts of North Africa and the Arabian Peninsula is this line right here that is around the yellow area there. And that line reads 200, which means that the received solar radiation is capable of evaporating 200 times the amount of rainfall. All of the numbers in here vary between 10 and 50. And these are incredibly dry deserts. Just to bring this home, the driest place in North America is right here in the US, is Death Valley of California, and the number for that is 7. So you can see how dry is dry with 200. Now when we look in that kind of terrain, we remember Mars, because that is almost the same kind of condition. Absolutely dry terrain, used to host water before, as we saw these buried rivers, but no longer has water, and the wind is the king. The wind is the only agent of transportation and erosion. And so when we look at the surface features of Mars, we see wind-blown features. Everywhere we see deposits of light-colored material with a little bit of reddish color from oxides of iron, something like oxides of iron, and you see these little dark streaks in the lee of topographic impediments. We see almost identical kinds of things in the deserts of the North Africa. Here is a case in Egypt along the border between Sudan right here and Libya on this side. You have this spindle-shaped dark area behind a large mountain, or behind a tiny little rock right here, a dark rock, and that spindle shape behind it like that, from the fact that there was a lot of light-colored material, sand, coming from the north, depositing around it on the left and around it on the right, and leaving this whole zone behind in the lee sand-free. And we only understood this after we made this investigation on the ground, where we have the hill and the sand deposited on that side and on that side. And because of the existence of this topographic impediment, this area here has been shielded from the deposition of sand. So it really is a sand shadow, so to speak. That explained things that we saw on Mars and we actually misinterpreted at the beginning. When we saw this feature was a crater with a dark thing coming out of it. So we said, aha, a volcano. Here is the crater with the volcanic thing and the stuff that came out of it. Whether it is a lava flow or whether it is an ash deposit, it's the same thing. But turned out not to be the case, because that was the explanation. There is a crater, meaning a rise. All of the white material in here is wind-blown sand, came out this way, hit the edge of the crater right here, veered to the right and veered to the left, left this whole area behind the crater free of sand. That's why it is dark. So that is the original surface of Mars, and that is the deposit of wind-blown material, very much like this here. So we actually figured out what this Martian feature is after we studied the Earth landform.